So keeping in mind that the degree of the numerator always needs to be 1 less than that of the denominator, we can write this as a over x plus 1 plus bx plus c over x squared plus 2 plus dx plus e over x squared plus 2 whole squared. We multiply both sides by the denominator x plus 1 times x squared plus 2 whole squared, and we end up with this equation. Now, to find the values of constants a, b, c, d, and e, I will show you a few different ways just to cover all the bases. So, to work out the value of a, we can set x equals to minus 1 on both sides of equation 1, which of course cancels these two terms to leave us with 5 equals to a 1 plus 2 whole squared, which gives us a equals to 5 over 9. Now for b, we can compare the coefficients of x to the 4 term on both sides. So on the right hand side we get ax to the 4 plus bx to the 4, and of course there is no x to the 4 term on the left, so the equation becomes a plus b equals to 0, and therefore b equals to minus 5 over 9. Now for c, we can compare the coefficients of x cubed terms on both sides. On the right hand side we get bx cubed plus cx cubed, which is equal to 0, and therefore c equals to minus b, or in other words, c equals to 5 over 9. Then to work out the value of e, we can simply set x equals to 0 in equation 1, and that then yields 5 equals to 4a plus 2c plus e. So plugging in the values of a and c, we get e equals to 15 over 9. And then finally, to work out d, we can compare the coefficients of x on both sides. So we get 2b plus 2c plus d plus e equals to 0. So plugging all the values that we've worked out, we get d equals to minus 15 over 9. Therefore, the final partial fraction decomposition becomes